our first example, we have a 25.0 milliliter sample of hydrochloric acid is titrated with a 1.00 moles per liter sodium hydroxide solution. The endpoint is reached when 67.5 milliliters of base has been added. Calculate the concentration of the acid in moles per liter. Now, titration problems are simply stoichiometry problems. The first step in stoichiometry, or in our titration problem here, is to write a balanced chemical equation. We have hydrochloric acid reacting with sodium hydroxide. This is a neutralization reaction, so it is going to produce water plus an ionic salt, which is sodium chloride. Our second step then is to determine the number of moles of our known quantity. In this case, we know the concentration and the volume of sodium hydroxide, so we can determine the number of moles of sodium hydroxide that we have by multiplying the concentration times the volume. When we do so, we get 0.0675 moles of sodium hydroxide. Our third step is to use a mole ratio to determine the number of moles of our unknown substance. Because our reaction is reacting in a 1-to-1 ratio, so 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid, the number of moles of hydrochloric acid will also be 0.0675 moles. Finally, we have to determine our unknown value and convert that to the units the question requires. In this question, we require a concentration in moles per liter. So we are going to take our number of moles and divide it by our volume. Our volume given is 25.0 milliliters. When we do so, we get 2.70 moles per liter. Therefore, the acid concentration is 2.70 moles per liter. The second part of our example asks us to calculate the percentage of hydrochloric acid as a percentage mass by mass in the solution given above, given that its density is 1.100 grams per mil. What we need to do then is look at this question and this calculation in two parts. We're going to first look at the 2.70 moles hydrochloric acid, and then we're going to look at the second part, the 1.00 liters of solution. Focusing on the first half of our equation then, 2.70 moles of hydrochloric acid, we need to convert that into a mass. To do so, we're going to use the equation mass is equal to the moles times its molar mass. In the concentration we have 2.70 moles. We are using the molar mass of hydrochloric acid, which is 36.46 grams per mole. That gives us 98.442 grams of hydrochloric acid. We now need to convert the 1.00 liters of solution into a mass. To do so, we're going to take its density, given in the question, as 1.100 grams per mil, and multiply that by its volume, converting the volume from liters into milliliters. Doing this calculation gives us 1,100 grams of solution. We can take these two components then to determine the percentage mass by mass. To find that, we're going to take the mass of HCl and divide that by the mass of solution and multiply that by 100%. Taking the 98.442 grams, dividing by 1,100 grams times 100 gives us 8.94927 ... Therefore, we can say that the hydrochloric solution is at 8.95%.